Waiting for everyone to file in, waiting to see if we're live. Sophie did such a good job last week of not having any awkwardness in the first 20 seconds of the stream.
I don't know. I honestly don't know how I did that. But hopefully, I don't know. Hopefully I can repeat it someday.
Yeah.
The timing, right? Cool.
Let's see. Okay, cool. We are up and running.
Yay. Awesome. Hello, everyone. Dr. Monkey UK. It's always the first one to say
God,
hello.
the best.
It's awesome. Let us know you're here. Welcome to the eighth and final stream in this series. Potentially, we have more content in the Master Stats with Python path coming out. So maybe someday in the future, we'll do more streams like this. But this is the last one in this series. So we're really excited to jump in today and do some and have a conversation about A/B testing, which I feel like is a very commonly used but sometimes misunderstood way that statistics gets used in a lot of different industries and a lot of different companies. So I'm excited to dig in. Per usual, we are looking at the YouTube chat. Hi, Jamie. And hi, Dr. Monkey UK. If anybody else is here, say hello. Let us know if you have any questions. And feel free to join us in coding on your own computer if you would like.
Yeah, before we get too far into this one, I'll do a plug for our upcoming series. After this one is over, next week we're starting another one with G1, another curriculum developer is going to be leading it about kind of creative coding and specifically using JavaScript and a JavaScript library called P5.js. So I'll plug that more at the very end of the show. But yeah, we're doing another series starting next week.
It's going to be super awesome. I'm going to watch all of them and finally learn some things.
Yeah.
So yeah, very excited. All right, I'm going to share my screen. Let me make sure this time that I get the right one. Cool. Can you see that, Alex?
Yes, that looks good to me.
Okay. Suddenly, usually I can see your face somewhere on the screen, but now I can't see. So you'll just be...
I'll be here.
You'll be just a voice somewhere in the background. All right. So like I said, today we're going to be talking about A/B testing, and we're going to approach this in a similar way to the other content that we've approached, or the other statistical concepts that we've learned in this series. We're going to think about both a researcher perspective, so someone that works at a company, and then we're going to think about a like all-powerful perspective. If you had all the information you could possibly have in the world, what decisions or what would you then be able to glean from this process? So a little bit of background.
Sophie, and before we go too far, I also wanted to plug that for the last 15 minutes or so of this stream, we're going to bring on Dan Layfield, who is a product manager here at Codecademy. He runs a lot of the A/B testing that we do, and so we can ask him kind of what this looks like in the real world. So yeah, another thing to think about if you have any questions that you want to ask somebody who's implementing some of these statistical concepts. We'll try to leave like 10, 15 minutes for Dan.
Exactly. Yeah, I'm super excited because I think I like to focus on a lot of the theory, or I have focused on a lot of the theory in these live streams. And so to have somebody that is actually implementing this in real time, I think is a really nice complement to everything that we've been learning. So cool. Okay, so I guess the thing that we should start with is maybe just talking through what an A/B test is, or like what an A/B test is kind of used to do. So Alex, I mean,
yes.
You're not an expert in A/B testing, but I'm sure you've seen some A/B tests before, seen some results, or heard about them. So can you give like a 1-minute explanation of what you think an A/B test is all about?
Sure. So my general sense of what an A/B test is comparing two different options of something and comparing the results of those options. So we've talked about this with curriculum development, where we don't actively do this, but it would be something great that we would love to be able to do, is like, oh, here's a paragraph about for loops written this way. Here's a paragraph about for loops written the other way. Which one is better? Or which one do learners find easier to understand or do better on the quiz, or whatever that metric is that we're interested about. We compare those simultaneously. And I think one thing that we could do is run paragraph 1 for week 1 and then edit it and run paragraph 2 for week 2. But I think one of the main important things about A/B testing is that it has to be like run simultaneously, right? Or you try to like keep the groups that are interacting with the content as similar as possible, I guess.
Yeah, we can definitely talk about that a little bit. But yes, I think in an ideal world, you want to set up your experiments so that your two groups that you're comparing are identical or your two or more groups that you're comparing are identical in observable and unobservable ways. And the only way that you can guarantee, or that you can make the groups balance based on unobservable characteristics, is by using randomization. And so that means that like you basically have to have a group of people and then randomly assign them to groups. And if you do it based off of something temporal, like time, like the first 500 people and then the second 500 people, then those groups are no longer randomly.
Right. You could argue that the first 500 people had some different motivation or just a different group of people compared to the second 500.
People, maybe people who are accessing Codecademy between the hours of 8 a.m. to 5 p.m. GMT are different than the ones that are accessing it from 5 p.m. to the next 8.
Right.
So, yeah. So one thing I'm going to do, so that was a great explanation. And one thing we're going to do here is we're going to actually simulate some data that might look like data that came from an A/B test. So I've written out some code to do this here, but I'm going to write out that code in front of you guys right now, again, so that we can talk through what it's doing. So let's imagine for a minute that we're interested in two different versions of a subscribe button, and we'll call them like version A and version B. And we want to know whether version B or version A is better in terms of the proportion of people that are going to click on the button if it's surfaced to them. So it's a stupid example, but we're just going to go with it for simplicity.
What a great plug to subscribe to our YouTube channel and Codecademy Pro and all of our various things we want you to subscribe to.
Exactly. We'll pretend that we're trying to get you to subscribe to our YouTube channel. And so we can imagine for right now that we have some subscribe button that we're already surfacing to people. So let's call that the like A button in the spirit of A/B testing. So let's say we've got our A button that is the button that we're using now. And based on historical data, about half of people who see that button are clicking it. That would be a very high rate, but we're just going to pretend like that's how popular we are. And then let's say we want to know if some new button that we're going to design is going to be better than the button that we already have. And let's say that we'll feel like it's a better button if it performs such that 60% of people click on it. One quick note, and this is just like a vocabulary thing. So you'll see, right, that our existing button has 50% rate. Our new button, we're hoping, is 10% higher, so a 60% click rate. The difference between these two numbers is 10%, but a lot of the time people will use another word called lift, which often or is generally reported as the percent increase of these percentages. So that sounds complicated, but basically what it means is 60%, right, is what I believe, am I doing this right? 20% higher than 50%.
Right. So looking down, I'm already like looking ahead to that other block of code where you have 1 plus lift times A rate. So if we want B rate to be 0.6, that lift is going to be, it's not going to be 10% because that'll be 1.1 times A rate, which would be 0.55. So yeah, I think it's going to be 20%. But so you could do a little bit of algebra to figure out what that lift is based on what percentage you actually want the B rate to be.
Yeah. So I'm not going to go into too much detail on that, but for the time being, let's say that the A rate was our baseline rate that we already have is about 50%, and we want to see if we can increase that to at least 60%. So let's simulate some data then. So I'm going to use the same random functions that we've been using prior to this. So I'm going to use the numpy.random.choice function. I'll just copy these over, but we'll change things around. We'll like hard code some of these numbers just so that you see what's going on. So let's say we show this button that we've, in our experiment, we're going to show this button that we already have to 100 people, right? And we're going to simulate some data where for those 100 people, they have a 50% probability of clicking the button and a 50% probability of not clicking the button.
Yeah, and so this syntax looks really similar to in previous lessons when we were flipping a coin, right? The coin could either be heads or tails, and we said, okay, a fair coin is 50-50, but sometimes we were flipping an unfair coin where it was like 90%, 10%, right? And so that's what that p value is, or that p array is doing, is saying the odds of getting yes is the first value, and the odds of getting no is that second value. So for A rate, it's 50-50, and for B rate, it's going to be 60-40, I guess.
Yeah, 0.6, I guess I can put in the actual numbers in here. So later we can kind of code these with things like A rate, 1 minus A rate, B rate, 1 minus B rate, but just so that we can read this super easily, let's just put this all together so you can see. Okay, so if we simulate some data like this, so we're simulating again data where people have a 50% chance of clicking the A button, they have a 60% chance of clicking the B button, then we can kind of assemble this in a data frame. So I'm gonna put together a data frame where I'm gonna have a column that tells me whether or not someone clicked a button, and I'm gonna have a column that tells me which button they saw. So to do that, what I'm gonna do is I'm actually going to combine these two arrays into a single array. And there's a bunch of different ways to do that. I have grown to really like lists in Python, so in terms of like appending arrays or appending lists and like
it's happening. Sophie joined Codecademy and was a huge R fan, and I was always the Python guy, and now she loves Python lists.
Yeah. Well, they are pretty nice. I think that base Python is like easier than base R in terms of like general programming things. Yeah. But in terms of actually doing an analysis or like running statistical
it's really easy to do that in R
it's so
and in
much
Python.
easier to do that in R. Yeah. Okay, so if I do this really quickly, I'm just going to show you guys what this looks like. If I just add these two lists together, all it's going to do is it's going to take this list and append this list onto the end. So it just put all of those together.
So we just have to know that the first 100 were the people that saw button A and the second 100 are people that saw button B.
Exactly. So yeah, the first 100 are the people that saw button A. And so now I'm going to make another list to go alongside this one that says, so this is going to be clicked, or outcome, maybe we'll call it. And then we'll make a second list where we have 100 A's and then 100 B's, so it can kind of line up right alongside this one. Cool. So I'm going to do list A, or sorry, list where I put an A, and I'm gonna, this is why I like this. You can do that, and that will just repeat it 100 times. So let me print what this looks like. So what I just did was created a list with 100 A's in a row and then 100 B's in a row.
Yeah. One thing, and maybe some Python experts in the chat, I'm always a little bit hesitant to do that. I think with like objects, those might all, when you use multiplication with a list, it might all point to the exact same object. So it's like if you edited one, you'd be editing all of them.
Oh, really?
But I think strings might be different. Honestly, I don't even know if that's true, but I've always been a little bit hesitant to use that. It's good to check to make sure that these are not all copies of each other if you're using multiplication like that.
Wow, I did not know that. Well, I know that this works for what I need it to do once I turn it back to a NumPy array. So I think it will be okay, but that's super interesting.
Yeah, and that might not even be accurate, but for whatever reason, I've always been slightly paranoid about using that that multiplication with lists.
Well, then now I don't like Python anymore. Jokes. Okay. Here we go. Let's see if we can. This. Okay, so here is our simulated data where the first 100 rows saw group A or saw button A, the second 100 rows saw button B, and then we have simulated information about whether or not they clicked the button. And every time we run this, we're going to get a slightly different data set, but the probability of clicking in group A versus group B will be the same every time. So right now I see yes, no, yes, yes, yes. And if I run this again, now I've got yes, no, 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 no. So it's going to be slightly different every time.
Yeah. Sophie, one thing that we haven't really talked about as we've been doing all of these exercises where we're simulating stuff by like random distributions is we've never talked about how to like seed your random number generator and why you might want to do that. Can you talk a bit about like what it means to seed your random library?
Sure. Yeah. So I think one way, and here I'm gonna actually, just to make this a little easier to see, I'm gonna print a cross tabulation of this. Do data group, data clicked. So that we can see like 4 numbers instead of, oops. Yeah, so we can see 4 numbers instead of the whole data set. Okay, so like Alex was saying, when we run something that's like when we use a function that is using some sort of random number generator, we sometimes might want to like write our code in a way that another person could replicate it. So if I pass this code on to Alex and I want to say like, this is what I did, and I want you to see the same output that I got, or if I want to have him like replicate exactly what I was doing, that gets really difficult when you've got random functions in your code. So one thing you can do is you can set a seed. I think just like
Let
random.
me look it up as you're doing this. It might be np.random.seed, but yeah.
I think it's like random. I don't know. Let's try it.
Yeah, I think that'll do it.
Okay, so now you'll see, right, this time we got 50. We'll just focus on this number, 51. But you'll see now that I've set a seed, I should get the same numbers every time I run this. So even though it's a random process, I'm generating the same random outcome every time I run this by setting the seed. And you could set this number to anything, and every unique number that you input or every unique seed that you input will give you a different result. But like, as long as you use the same random seed, you'll get the same result every time.
Yeah, compared to if we delete that line and just keep running it, those numbers are going to be bouncing around, right? They're going to be different each time. I find this helpful. I use this a lot in my like coursework when I would be working on a problem set that somehow involved random numbers, and I was like trying to debug my code or trying to like trace through my code to understand what's happening. And it's really difficult if some part of that is changing every time you run your program. And so, yeah, I find it helpful for debugging, where it's like, okay, that these numbers are always going to be the same, even though they're still random. And that way you can kind of like trace through what's happening.
Nice. Yeah, that's super helpful. I feel like I use this a lot if I'm ever trying to do an analysis where I need to use a function that has some sort of random generator. Like a lot of machine learning algorithms even have use some sort of random process as part of fitting the algorithm. So like trying to find the minimum of some surface, you'll start in random places on the surface or something to try to converge towards the minimum. And so you get slightly different numbers every time. And if you want your research to be reproducible, which is a really good practice, or you want somebody else to review your work, then it's a good idea to use a random seed, because then somebody else can verify that they get the same result.
Cool.
Yeah. Okay, so now that we have this kind of fake data set, we can think about what we would do as a researcher if we got this data. So if we were working at a company and we saw, we ran this experiment and we saw these numbers, we saw in group A, 47 people did not click our button and 53 people did, versus in group B, 37 people did not click the button and 63 did, we might think, okay, well, this looks at least somewhat convincing that a higher proportion of people are clicking the button in group B. And now we want to know, is that sustainable if we run this experiment again? So same way as we were discussing last week and the week before, hypothesis testing is really built around this idea that you can only observe a sample, but you want to know something about a larger population that you can't observe. And in the case of this fake A/B test that we're running, the larger sample that we can observe is all the users who could ever, or all the visitors to YouTube that could ever view this subscribe button either way. And we can't see what all of them would do. So we only want to change the button, because it takes some effort, if we feel reasonably confident based on our sample that we'll still see a higher rate of clicks among the larger population to whom we surface these buttons. So we're going to run a hypothesis test. I don't think we've gone over this particular hypothesis test in one of these sessions yet, but depending on what kind of A/B test and what metric you're interested in, you might use different hypothesis tests. In this case, you can kind of think of this as two categorical variables, right? What group you're in and whether or not you click something. And so the outcome we care about, because it's categorical, it's like, do you click or not click? One of the hypothesis tests we could use here is a chi-square test. If the outcome we cared about was something quantitative, like how much time they spent watching our YouTube video or something like that, then we would need a different kind of test. So I'm just going to demo running this test. I'm not going to go into the kind of specifics of what's involved with the test, but we can come back to that if there's time. I just want to make sure that we have time to talk about that, the results and why they're interesting. So I believe, let me just I'm going to grab the test from here because I always forget what the function is and the order of the parameters.
Sophie, do you want to roast me about the chi-square test?
Oh, one of my favorite stories, or one of my favorite moments from when we were building this stats curriculum, is Alex thought that the chi-square test, which it's totally valid, you're not wrong, thought that it was pronounced chi, like the T, and I don't know, it just made me laugh.
Sophie's the stats expert.
No, I mean, like, chi is a Greek letter, right?
Yeah.
But now whenever I think of it, I think of like someone eating or drinking 2 cups of tea, and it makes me happy.
Yeah, A/B test the tea.
Okay, so what I'm going to do is I'm going to save this contingency table as A/B contingency, and that's the input that I give to this function. So basically, when I run this test, I input this 2x2 table, and then it's going to give me a p-value, which is testing the null hypothesis that there's no association between these two variables. So there's no relationship between the group identity and whether or not somebody clicked.
Okay.
I'm seeing some questions in the chat. Are we looking to see that the observed higher rate of clicks is not just higher lift, but is 20% higher before then checking to see if it translates to the greater population with our hypothesis test? So that's a good question. So I think it will become a little bit clearer in the next step. But for right now, let's just imagine that we are all powerful and we know that these are the true rates. When we come back to the next piece of it, we'll talk through how if you're the researcher and you're planning an A/B test, you have to think about how big of a difference you care to measure in your test. So once you have some data, you definitely want to measure what is the rate in group A, what is the rate in group B, and how large is that, and then run the hypothesis test to see if that's a significant difference, right? That you can reject the null hypothesis that the different, or that the association does not exist, or that you can reject the null hypothesis that these numbers are the same. But
so Sophie, I guess the question that I have then is, do you set those rates? You set those rates before you view the samples, right? Where it's not, because I could see a world where you're like, okay, we've like made this change. We see that group A got 53 yeses, group B got 63 yeses. Is that a real difference, right? Like I could see coming up with those rates after the fact, after getting the 2 samples. But
yeah, so basically I will explain this in the next step, but for a hypothesis test or for an A/B test, usually you're comparing, and we can ask Dan a little bit about this later too, but oftentimes you're comparing something that already exists to a new version.
Okay.
Right? And so you'll have some baseline data. So you'll probably know this number, right? You'll know like the thing that already exists, how does that perform on the website? But then you're not going to know what this number is.
Right.
The only thing that you need to decide before the test is how big of a difference you care about. Because, for example, right, there could be a true difference, but this could be 0.50001. Right. And like, you could have a test that detects that difference, right? We call that like a effect size, and this would be a small effect size or a small lift. So you could design a test to detect that difference, but you probably don't care about it. So we'll come back to this when we come back to the kind of researcher side of it. But for right now, let's just imagine that these are known rates.
Okay.
So if these are known rates, we could generate this data set. We could run our chi-square test. The null hypothesis for the chi-square test is that there's no association between these two things. Another way of thinking about that is that these two rates are the same. And then we can print our p-value and see whether we reject the null hypothesis that there's no association. And in this case, we wouldn't. Ooh, that's surprising. I would think that why am I getting, oh, there we go. So in this one, we got 0.002. It's surprising that we got a p-value of 0.57. I would have thought that with this big of a difference, we would usually reject the null hypothesis and think that there was a significant difference, but I guess not.
Could it be sample size of 100 isn't big enough?
Maybe. We'll have to come back to this. So I think this is the next interesting question once we get in a little bit further into our simulation. Let's make this a bigger difference. Let's make it like.
And then that has to propagate through clicks B, right?
Oh, that's right. Because I hard coded it. Yeah, so now I'm getting smaller. I'm getting small p-values.
Yeah.
Right, so if this p-value is small enough below some significance threshold, then we reject the null hypothesis and we say that we think that these things are associated, which in the case of this example would lead us to believe that the B rate was, or the B button was better at getting people to click on our button. Okay, so let's now zoom back out and let's do what we've done a bunch of times and put this all into a for loop and then think about what happens when we run the same random experiment a bunch of times. And each time, let's think about whether or not we get a significant result. As I'm setting this up, Alex, do you want to talk through, so I'm thinking from the perspective of a researcher, what do you think are some of the some of the things that are some of the considerations that you might want to take in terms of how you design this experiment? Like, do you think that it's just always good to have as large of a sample size as you could possibly get? Or do you think you want to prioritize like how the size of the difference that you're trying to measure? Do you have any ideas for like, what are the considerations that you might have to take into account as you're trying to design this?
Yeah, interesting. I don't know if I have anything that sticks out to the top on the top of my head, but yeah, I would say that in general, I would assume that getting as large a sample size as possible is good. I would, again, another thing that I kind of, when I hear about A/B testing, the thing that I hear about is like trying to get the groups as random as possible or as similar as possible, and randomly split up. So doing things like making sure that they're kind of interacting with this at the same time. What could other be? What
do you think? I'm trying to like ask you
lead me.
Questions, but come up with the right way to frame them. What is So let's say that there's a real difference between two groups. Like, let's say that button B really is better than button A.
Right.
But it's only a little bit better. And it's hard for us to measure it. There are two different ways that we could make a mistake. Or in this case, there's one way that we could make a mistake. We could make a mistake by not finding that difference, even though there is one.
Right. So that has to do with like p-value, right? And what p-value we consider being significant or not.
Mm-hmm. But on the flip side, if there's no difference between the groups and we make a mistake and we find that there is a difference, then that's also not a great thing. And so maybe can you walk through from the perspective of a company, like how someone might think through those considerations? Like what goes wrong when you make each of those kinds of mistakes? Or what could go wrong if you make either of those kinds of mistakes?
Like practically what could go wrong? Well, so like ultimately these tests result in some decision being made, right? And so if and I'm not going to know whether it's type 1 or type 2, but if it's if you say that you found a significant difference and like, okay, let's go ahead and implement this button, and there's really no difference, then that's a lot of wasted work to go and make that change. And I suppose the opposite is true for the other type of error. If you find that there's no difference, but there really is one, then you've missed out on this opportunity.
Yeah. So, right. So exactly. There's two kind of things going on here where if there's a real difference, then you want to be able to detect it. But if there's not a real difference and you detect one, then you're potentially going to put resources into changing something that doesn't need to be changed or doesn't help you. Right. So there's kind of two different types of mistakes that you might want to think about prioritizing or not prioritizing when you're trying to plan an A/B test. So I'm going to just grab, because I'm conscious of time and I want to make sure that we have plenty of time to ask questions later with Dan. So I'm going to just grab some code from here. But essentially what I'm going to do, in fact, I'm just going to grab all of this and then I'll talk through what it's doing.
Yeah. Sophie, while you do that, we have a question from the chat of, and I think I know the answer to this, but maybe I'm wrong. Can this be used to hypothesize difference in male-female wages? Like, can you say, okay, male wages are group A, female wages are group B? Can that be something that you use this for?
Yeah, so you could use a different kind of hypothesis test for that. In that case, you're talking about an association between a categorical variable like male and female or whatever other genders exist, right? So you've got a categorical variable and then you have, or what's usually treated as a categorical variable, and then you have a quantitative variable, which is wages. And so if you're looking at an association between those two, then you would need a different hypothesis test, but you could definitely think about it in a similar way. You would probably use like a 2-sample t-test, or you could also use a z-test. Okay, so let me talk through what I've got here. So same as we had before, now I've rewritten this as lift, but I'm gonna just
put in 0.6 again, or yeah, 0.7.
Okay, so we've got a group A rate, a group B rate. We've got our sample size, which is getting split into the two groups. So actually here we've only got 50 in each group. Maybe I'll up it to 200. So we've got 100 in each group. We simulate our data. We run our chi-square test. And then we'll save the result in this list called results, where we'll save significant if the p-value is less than our significance threshold, and we'll save not significant if it's not less than our significance threshold. For right now, we'll use a significance threshold of 0.05. And then at the very end, we're going to calculate the proportion of the results that were significant, and we'll calculate the proportion that are not significant. Okay, so let's run this.
And so before we run this, we expect this to be a significant difference, or at least I would expect this to be a significant difference. And so I would expect that proportion to be pretty high if a lot of them are significant and not many of them are not significant.
Yep, exactly. So in this case, we've got 73% that are significant and 27% that are not significant. Cool. So let's talk through for just a second what situation we're in. So in this case, right, because we have a group A rate in this example that's different from our group B rate. So again, we're all powerful, all knowing. We know that these rates are different. We're in the situation where we want to reject the null hypothesis because there really is a difference, right? Like the correct answer would be a significant p-value.
Right.
So in this case, we've got that the proportion of significant results is 0.73. So 73% of the time we detected this true difference, and 27% of the time we did not. What do you think will happen? Like if I make this bigger, so the difference is even bigger, Alex, what do you think will happen? Will this number go up or will it go down?
I imagine it will go up. It seems to be like this. This is very similar to like how the p-value was the type 1 error rate, right?
Yeah.
So I'm guessing, yeah.
That will be the next question, but yeah. So exactly. So if I make this difference even bigger and I run this, now 98% of the time the results are significant. Right. So the point is here, the larger the difference between the two groups, the more likely it is that we'll be able to detect a difference when there really is one.
So can I ask like the inverse? What if these two groups are actually the same? And if they're actually the same, then shouldn't we expect to get, like if there was no randomization, then we would expect it to get 100% not significant, right?
So yeah, actually, what do you remember, or do you want to take a venture guess what the proportion of significant results will be if I do this?
Is this the p-value now? Is this going to be 0.05?
It's not the p-value, but it's going to be the
significant threshold. Yeah, that's what I meant. Yeah.
So it should be approximately 0.05. So this is actually what we were going over the other week.
Yeah, cool.
Right. So you'll see that, which is fun. Right. So we got to take into account exactly what Alex is saying. Two different types of mistakes. If the truth is that these two rates are the same, then we're going to make a mistake about the same percent of the time as whatever significance threshold we set for our test. And if the truth is that the rates are different, then we're going to be more likely able to detect that difference if it's large. The other thing that will help us detect a difference is the sample size. So right now, if we had this at 200 and we've got this proportion of significant results that's equal to 73%, if we up this to 400, we're going to get a higher proportion of results that are significant.
So what does this mean practically when you're like designing a experiment?
So practically, and that's where we're going to kind of move in, and we'll move into this discussion and we'll move into our discussion at the end, is practically the things that you need to know as you're setting up an A/B test are the baseline conversion rate, the lowest, and in this case, it's the smallest difference that you care to measure. So, right, we saw that as long as the difference between the two groups is some number or bigger, your probability of detecting a real difference is just going to go up, right? So whenever we calculate a sample size, we use a statistical power level of 80%, and that corresponds to, this proportion of results that are significant if there is a real difference between the groups. So here, actually, if we had a sample size of 400 and the real difference between the groups was 20%, then our power would be 99%.
So this tool is saying if we're only interested in 80% statistical power, then we don't need 400 people. We only need 100 people or something like that.
Yeah, we're basically saying that if we want power of at least 80% to detect a difference in rates of at least 10% for two different variants, how big is the sample size that we need? And that's what this calculator is calculating for us. And really the things that you need to know to plan an experiment are how big of a sample do we need for each group? You might need to calculate the duration. So like how much traffic do you have? And how long is it going to take you to show your buttons to that large of a sample size? And then, right, like how big of, and in order to calculate these things, you need to know, this is kind of the inverse of that significance threshold. So a 5% or a 0.05 significance threshold would be a confidence level of 95%. This gets written different ways in different online calculators that you might use. And then you need to know statistical power. And this is really like minimum detectable effect, which is the minimum rate difference that you would care to measure. Okay.
Should we bring Dan on? Sophie, I don't know if you can see him with the screen share, but Dan is here.
Oh, yay. Hi.
In fact, actually, Sophie, unless we want to show anything on screen, maybe this is best if we cut the screen share just so we can see each other.
Oh, yeah. Now I can see all of you. This is so much nicer than just talking into a screen. Welcome. So, Alex, do you want to give a quick intro and then?
Yeah, or Dan, I was wondering if you could introduce yourself, talk a little bit about what you do at Codecademy and how you run A/B tests.
Yeah, sure. So great to meet everybody. So I'm a product manager here at Codecademy. I've been at Codecademy about 5 years, been a PM for 3 years. Really the job of a product manager in a consumer-focused company like Codecademy is to like pick key parts of our user experience and try to improve them. I think like in an ideal sense, you're getting a chance to do a ton of user research and pull data together and then come up with hypotheses about like what could improve the user experience. Frankly, hypotheses you're really, really confident in, you have a bunch of great evidence for, you don't ship an A/B test because you just want to get the right thing out there as fast as possible. But A/B tests are great at deferring risk. So if you're really not sure about which one of two options is better for the users in the business, A/B tests are a great way of measuring that.
Awesome. That was a really great segue into, I've prepared a couple of questions, so I'll kind of walk through them. But it's a good segue into my first question, which is, I'm curious if you could talk about the kinds of questions that Codecademy tries to answer with A/B tests. Like what are some examples?
Yeah, so we've done a lot of testing for a consumer-focused company like ours. Like the bottom of our funnel is very important. So specifically, our pricing pages, our checkout pages, how our pricing looks, the pricing of the plans themselves is potentially like a really high leverage point in the experience, but also like a potentially really risky thing to change. So when we go do a bunch of product development work on things like our pricing page, like how exactly should we be conveying what's in the free and the paid product, is a great place to do testing. I don't know which, Sophie, which little experiment write-up you have, but you can probably pull up whichever one makes sense. And we can talk about exactly how that went.
Sure.
I think there's one on pricing positioning.
Let me share my screen again.
And folks in chat, if you have questions for Dan too, feel free to
happy to answer anything.
Throw them in chat and we can give it to him.
All right, let's see. Think. Give me 1 second.
Yeah, no worries. So I think like really the job of the product manager is to like deploy the resources of the company in the way that is the best for the business and the user base. So we're constantly trying to come up with ideas about what could be better in experience and then ship them and measure them. So here's a great example of a test we ran on our pricing page. So to test the hypothesis that like users might be more interested in our paid products if we conveyed the amount of content in the paid product versus just that there is a difference in content. So if you scroll down, I think the screenshots probably convey it the clearest. So really important in A/B testing is clear hypothesis, clear KPIs that you want to measure. And then the control and the variant was just like that. There is a difference between the free and the paid product. And the variant, zoom in a little, just displays like the number of hours of learning content, I think, versus the number of courses of learning content.
Yeah, so in the control there, that first line is hours. And then Sophie, if you scroll down to the other one, number of courses.
Yeah, and if I recall correctly, I think the course count lost, which kind of makes sense, is like hours of content is kind of like an opaque, confusing concept to users. We're really just trying to figure out like what is the best way of showing the difference between the products. My recollection is number of courses make more sense, which is a little bit more intuitive. So this is a great example of like something we legitimately didn't know the answer to and sits in like an important part of the application itself. So that like, therefore we want to test it, and tests like this also go on to inform other teams, like the marketing team, and how they display the paid content to other people. Because what's really important in testing is not necessarily like the exact designs that went into a controller or variant. It's the underlying thing that a user understands at a certain point in the journey. So this insight is like likely applicable to other teams at Codecademy who can help make the experience better for everybody.
Dan, I'm curious about when you are designing these experiments, are you doing the kinds of things that Sophie was showing off of, like using these kind of calculators to determine what's the sample size, how long are we going to run it for? Like, can you talk a little bit about actually implementing one of these?
Yeah, sure.
And what that looks like?
So I think we kind of start at the product development phase, like I was describing earlier. We'll pick apart the experience and really do as much research as we can to figure out what could be improved. From then we come up with kind of like a tiered list of like, what are we most confident in, what are we least confident in. The super confident things just get shipped. The things that kind of in the middle that are a little more risky tend to get tested. And before we do any tests, we want to make sure that the page we're running on has enough traffic that we can like get to a statistically significant conclusion in a reasonable amount of time. So like when we've honestly screwed this up in the past is like we put too many variants on a page. We do the math wrong and we realize like it'll take 4 months to get an answer here, which is way too long at a startup. Like really we want to be coming to conclusions in typically under a month unless the test is really, really high leverage. So like if we realize that we don't have the bandwidth to like ship 4 variants, maybe we cut the variant size down to 2 or 3, which then affects like how our design and engineering processes work, which means like hopefully we get to an answer faster and we have the designers spin up less variants. And maybe we'd ship tests in multiple rounds instead of all at once.
I'm curious if you all think a lot about minimum detectable effect before you start an A/B test. So like, do you think about how big of a difference do you care about before you try to plan out the sample size? Or do you try to estimate how big of a difference you think there will be?
It's a little bit of like chicken or the egg. Like if we know we don't have a lot of traffic on a page and we're doing something that's riskier, you need to make a bigger change to meet the minimum detectable effect threshold. So like if I want to say in that test you just showed, kind of makes sense that a tweak within a pricing grid would only be like a 4 to 5% change. Whereas like if we completely overhaul the design of the page, that may be a 15% change, which means it's a riskier test to run because there's more engineering and design hours that go into the variant. But we know like if we want to be statistically confident in a change where we don't have a big population size, like the change has to be order of magnitude really large to like observe that effect in that time threshold.
Yeah, that's interesting. And do you consider like I guess you could touch on it a little bit there, but the engineering resources or the design resources of like, okay, we think that this is going to be a large change, and relatively speaking, there's not a ton of engineering work that needs to be done here, or this change isn't going to be huge, but we can ship it within 3 days if we get some engineers working on it or some designers working on it.
Definitely. I mean, as a product manager, you're always playing the balancing game of like, in an ideal world, you're shipping the like lowest effort, highest impact, lowest risk work at all times.
Right.
So like a great example of a change that we didn't A/B test is on our pricing pages and on our checkout pages. We use the $ to denote our prices, which makes sense if you're in the US, but is confusing to users in Australia and New Zealand and Canada and Fiji, which also use the $. So like that, we're just confident in that, like denoting the currency with an abbreviation is clearer. So we don't test that.
Interesting.
Like ideally, in a perfect world, like we're finding little stuff like that constantly and just shipping it out really, really fast. But you inevitably get to areas of development that you just don't know the right path forward. And that's where testing is great.
I'm curious if you can speak at all about, once you have run a test, how you then decide whether or not you're going to ship something. So let's say you run a test and you detect a difference between the two groups, but it's really, really small. Do you still ship it as long as it's like incrementally better, or how do you what are some of the considerations that you
it's a good question. I mean, I think in tests that are themselves lower risk, like in areas of the app that don't get a lot of traffic or like away from the core flows, to me, the biggest risk is you had a winner and you didn't ship it, because those incremental wins do add up to bigger wins. So like if the overall risk is not that great, we probably just default to shipping it and then see if we can catch like a longitudinal difference in just observing the traffic on the page over a long period of time. So like in a really well-run testing program, like you have the analytics set up to like observe the test groups outside of the initial experimentation windows. Because we've run enough tests here that we've definitely seen cases where like we see a variant win during an experiment, but like outside of the initial observation window, it flatlines and goes back to being the same. Because maybe you're running on tests of like existing users and you just tweak something and it looks new, more people click on it. And those things can be like actually very hard to control for, like practically, like in a startup. But there's definitely things that are like higher risk that we'll want to have like really extend the observation window and be confident in our results. Like if we're changing like pricing or our trial model or like anything that, we use to pay all the bills around here.
That's super interesting, because it reminds me, we had the conversation before you joined about how this is it's a random process. And so even if there's a difference that you observe in a particular group, it doesn't necessarily mean that difference is true for the entire population, because you only observed a very small proportion of people. But I didn't think about the other part of that, which is that for the people that are just seeing a new feature, there's like some sort of maybe newness effect that is also playing a role. And so it's not fully.
Yeah, definitely. And I think like in ideal scenarios, like you're just shipping things to new users. So when we do things in the new first-time user experience or the homepage, like those are easier to control for, because a lot of people going through those have never seen any of these things before. But like if we wanted to improve like the 5th module of a course, like the population size is so much smaller that deep into the experience that realistically you'll never be able to control at our size anyway, just for new users.
I'm curious, is A/B testing a pretty common thing that product managers do? I know, or when I think about A/B testing at Codecademy, I like think about your team, and Sophie and I were talking about how we wish we did this more in curriculum, or it doesn't really happen all the, like we wish we could A/B test the curriculum itself that we write. So like what kind of jobs use A/B testing? Is it a lot of product managers? And if not, like how did you kind of find your way into the space?
Yeah, sure. I think it is heavily used in product management, and specifically in product management in consumer-facing companies. So if Codecademy was a primarily like B2B business, like A/B testing can be helpful, but realistically, most of your customers are on long-term contracts, and it's tough to really measure like a trial or a conversion event. And this like signals and the KPIs are a little blurrier. They definitely still do it, but really the consumer companies also have the traffic size where you have enough of a population to run a high volume of A/B tests. Like Booking.com and Facebook and Uber and Google are really like the companies that like have massive size and also like a ton of infrastructure built up. Infrastructure like is an interesting thing to mention there because like tests are not cheap to run. So you should be running them like as often as you need to defer risk, but no more. It's very tempting as like a product manager to want to ship everything as an A/B test because you want to know like definitively if you're right about something. Whereas like doing like longitudinal studies are less satisfying because data has variance in it anyway. So it's tough to say like if the thing you did is really like moving a business forward. But as you mentioned in curriculum, like it's tough to really control for these things, and you need a lot of like infrastructure and data science resources to like make a change, ship it, observe it. The engineering is much harder. So there's definitely like a cost to them, but they can be super powerful.
Yeah, it's super interesting. Wow. Thank you for joining us. This was really, really
no worries.
helpful. It's awesome. I think, like we were saying before, it's been a lot of theory in these live streams, but it's good to remember that this is a real tool that people are using in a job setting and using it to answer questions and build a business and make a product better. So it's really helpful.
Yeah, definitely. I mean, the theory is super important. Like without understanding like the theory, it's tough to like design and sequence these tests. But like testing is definitely like an applied science. Yeah. Where like there's a theory of how you're doing it, but typically you're in environments that you can't perfectly control. So you like adhere as close to the theory as possible. But frequently there's things in your way.
Yeah, for sure.
Yeah, it almost reminds me of physics classes where you're like in all physics classes, you're like wind resistance doesn't exist. And you're like learning about theory, and then you come to apply it and you're like, wait a minute, there's a million different factors here. That
if you could perfectly isolate these things, it would be awesome. But like in reality, you can't. There's tracking problems.
Right.
There's other teams working in areas that you can't work in. So the theory is key, but it's really just like applying it in the best way.
Yeah. And also knowing how the theory relates to the actual practical applications, like understanding that your sample is not actually a random or a perfect representation of the population you care about, which in this case is like all users that might ever access this. And there's no way to ever get a random sample from that population. So
the application is very hard. Like even if you ship tests to like a 95% statistical significance level, it means one of every test, 20 of your tests could be wrong.
Right.
And if you ship enough tests a year, you definitely have a bunch of those that you're measuring wrong, just practically.
Yeah. Yeah. And I think it's also a huge issue at those bigger companies that do have infrastructure. If they're running like thousands of tests at a time, then it's hard to make decisions based off of that because you know that you could be making errors.
Exactly. Like tests overlap, they conflict. You get the observations you're seeing don't hold with time. Like it is messy in reality, but it's still super powerful.
Yeah. All right. I think we are just about at time, but I'm just checking the chat to see if we got any questions. I don't see any.
Yeah. Let me do a plug. So, well, first of all, this is the end of this series. So congratulations, Sophie. You did 8 weeks in a row of this. So thank you for running really amazing sessions. I learned a lot, and I think you did a great job. So thank you, Sophie.
And thank you for helping with all of them.
I just like sit here in the background for most of them and occasionally say something. So
that's not accurate at all.
Next week, we are starting another series. Again, it's going to be on creative coding, some really cool projects that Jiwan is going to go through. I'm putting a link in the chat right now to our events page. You can find all the events there, which will actually send you to the YouTube pages, even though they're not publicly yet. But keep an eye out on our YouTube page, because shortly I will publish all of these events, so you can see when we're running them. Current plan is to keep doing them on Thursdays at 4 p.m. But we might actually change that as we're going. So keep an eye out on that events page, subscribe to the YouTube channel, all that good stuff to know when we're doing stuff.
Awesome. All right. And with that,